Unit 3 in Principles of Operating System is concurrency. So, before going to the topic, you have to learn about what is process. Process in the sense single line executions. The process can be executed in concurrent way. The concurrent across the multiple processes are being accessing at the same time, in the sense you need to execute all the process in a cooperative way, otherwise there is some problems may occur. So the first one is a race condition. The processor P0 and a P1 are creating a child process using a fork system call. The race condition may occur while both the processes are trying to enter into a critical section, so that they need to create one request ID and response ID. So through this method, to avoid the race condition. Next one is critical section problem. While the multiple processes are tried to execute it at the same time, the critical section problems may arise. Actually, only one process in a critical section, in the sense the remaining processes are needed to be waiting in a waiting state. If all the processes are trying to enter into the same critical section, in the sense the problem may arise. If a process entering in a critical section, in the sense the remaining process need to be wait or in a exit sections or a reminder section. So if there are in a reminder section, in the sense the problems are being solved. So this is a critical section. While one process enter into the critical section, in the sense the remaining process needed to be wait until the critical section process get to be exit. Critical section problems are mutual exclusion, progress, bounded wait, interrupt based solutions. So the interrupt are being solved, you need to fix the entry section as well as the exit sections. One of the solutions are to solve the critical section problem is to use a load and store instructions. One of the instruction in a critical section, in the sense that condition is called in load, remaining section needed to be in a reminder section. If the process are being executed in this order, in the sense the critical section problems are being solved. To solve the problem, the Peterson solutions are used through this keyword load and store. One process enter into the critical section, that means loaded into the critical section, in the sense when a flag in the sense the process are being waited in a reminder section, turn in the sense currently the J processes turn on into the critical section, so that the turn equal to J, in the sense turn on to the critical section. The remaining process needed to be wait. After the completion of J, the next process or try to enter into the critical section problem, in the sense the critical section problems are being solved. Memory barriers. Memory models or the memory guarantee a computer architect to make the application program strongly ordered and weakly ordered. Strongly ordered, in the sense when a memory modifications of one process is immediately visible to all other processes. Weakly ordered, in the sense the memory modification of one process may not be immediately visible to all other processes. Synchronization hardware. Many synchronization hardware tools are used to solve critical section problems. The first one is test and set instruction, compare and swap instruction. You first test whether only one process in a critical section. So the next process are enter into the reminder sections. Next one is compare and swap. You need to compare that process is already in a critical section. For that, you have a three variables. One is value, expanded, and a new variable. You need to check whether compare the present one is equal to an expected one. If it is matched, in the sense you need to perform the swapping operation. Through this way also, the critical section problems are being rectified. Next technique is a mutual lock. The mutual lock is another way of synchronization tools used to solve a critical section problem. They uses two keywords. One is acquire and release. One of the process acquiring a lock, in the sense a remaining process needed to be wait until the acquired process get to be move on to the releasing section. So here one process acquiring the lock, so that process in a critical section, in the sense so the remaining process needed to be waited until the log get to be released. Next concept is a semaphore. Semaphore is another synchronization tool used to synchronize a process with the keywords of wait and signal. One process in acquiring a signal, in the sense the remaining process are needed to be in a waiting state. If the process releases the signal, in the sense another process try to acquiring a lock. So through this way also the semaphore problems ought to be solved. Next concept is a monitor. Monitor is another synchronization tool used to solve a critical section problem. Here the multiple procedures are tried to accessing at the same time, in the sense it will be treated like everyone be alike, and it will monitor the entire activities and treat every process as a procedure. The procedures are being executed based on the queue order. The next topic in Unit 3 is a deadlock. Deadlock is the multiple process are tried to waiting for a same resources. The circular waiting of a resources, that condition is called it as a deadlock. The deadlock resources are being processed like a request, use and release. The deadlock problem also solved with the help of the semaphore with the keywords of wait and signal. Here the two process semaphore 1 and 2 that being processed with the two thread T1 and T2. The T1 process waiting for semaphore 1, at the same time for semaphore 2 the T2 process is also waiting for same semaphore 2 and semaphore 1. Both the threads are waiting for the same semaphore 1 and 2. So this situation is called it as a deadlock. This deadlock are being overcome with the help of mutual exclusion, hold and wait, no preemption and circular wait concepts. So this is the graphical representation of a deadlock. The T1 process need or resource R1 to complete the task. R1 is holded by the T2 thread. The T2 thread needed R3 resource to complete the process, but the R3 is acquired by T3. So the T3 needed R2. R2 is holded by the T1 and T2. So this is called it as a deadlock. The continuously circular waiting of same resources, that situation is called it as deadlock. The deadlock are being handled with the two different cases. One is deadlock prevention and deadlock avoidance. The deadlock prevention, while the process are being executed in a mutual exclusion way, hold and wait method, no preemption and circular order, the deadlock are being prevented. The avoidance methods are you needed to follow. You check whether the process are being in a safe mode or unsafe mode. If it is in an unsafe mode, means the deadlock becomes occur. So you needed to calculate with worst case without +1 rule and check with the +1 rule. If it is meet out with any one of the cases, the unbecome state move on to the safe state. Safe state in the sense that process are not depending on the circular waiting of resources. So that process are being executed in a safe mode. Unsafe mode in the sense they may facing with the deadlock problem. Thank you.